I'm hoping that we've kept good pace as well as covered all the material that we need to cover, and so it's important that you guys chime in and say, if there are particular topics that are still confusing, or if we went too fast in certain areas and we left behind a lot of people, which is what we don't want to do, right? So it's important that you guys tell me, because now we have the time, right? We only have 3 more classes left. Well, actually, you know what? I'm happy to talk on, we'll give you a class on Thursday. I think I mentioned this before, but I will take a poll again. Someone remind me to take a poll after everybody's here, maybe in a half hour or an hour, to see if you want a class on Thursday. It doesn't actually have to be a technical CS class. In fact, honestly, you can, let's just make it an Ask Me Anything class, right? Because it's an unofficial class on Thanksgiving Day morning. So you can ask me any damn thing, okay? You can ask me personal questions. You can ask me what I do in situations in life. Anything that is safe for me to answer, meaning that you're not asking for bank accounts and social security numbers out on the web for me to give out on the web. I'm happy to answer, right? I don't have anything to hide. So you can ask me, but maybe it's not directly related to computer science, but maybe you have a question that may be indirectly related to computer science. Maybe, situations that will help you take exams better, or learn computer science, or learn math or computer science, those kinds of subjects better, right? So you can ask me any damn thing you want, okay? And but we'll come back to this topic in a half hour. What else have we covered so far? I mean, we started with data representation, branching, looping, arrays, classes and objects, utility methods, functions. Oh, we've covered quite a bit of useful stuff. Enough to get you completely prepared for CS2E. And because in CS2B, so CS2A, the thing about CS2A is that it's not only an introductory course, but it's also a sampler course. Right? An introductory means it's an entree, which means that someone like an appetizer who comes into a meal and they get a dish. And the idea behind the appetizer is that, well, that's not your entire meal. There's more to come, but this is your starter. So finish the entire meal and then go home, or something like that. But it's the sampler is different. A sampler is something that you have, in Trader Joe's, or in places that want you to just try it out and tell if it's your cup of tea, right? So if you go to Tivana, right, you have all these different teas and taste them to figure out which one you like, right? And so CS2A, CS1A, 3A, the A courses, really, they're all samplers, because they're not intended really for, well, they are intended, but they're not exclusively intended for CS majors, right? And meaning that students who do CS2A are interested in programming and C++, but not necessarily already committed to majoring in CS, right, or diving deep into algorithms. And so it's important that it has enough of a taste of programming for you to be able to tell if this is what you want to do, right? If this is your calling in life, or it is one of your callings, right? So, and from that perspective, we just need to introduce all of the concepts that will be useful for you to go ahead and build your own things and play around, because yeah, that's really what it is, right? It is a course that teaches you the rules of the game so you can go and play on your own. So it's basically just, just learning the rules of the game, right? um, and so the expectation is not that you would come back to do CS2B, but that you would go away from CS2A with a good memory, pleasant memories, saying, well, I did something that was really cool. It's not my cup of tea, but I can see it becoming my cup of tea sometime in the future, when I need to do it. So you come back at that time and say, well, I want to get deeper into it. At least you are not getting back to it saying, oh, geez, I need to go back to that course and that subject. But you're saying, hey, that was really fun. I want to go back and try it out. So maybe this time around, I'll find something more interesting, right? So, and so that's the idea behind CS2A, is to be a sampler, while at the same time, for the students who intend to come back and do CS2B, they would use CS2A as a solid primer, in the same way as the data representation module was a primer for CS2A. CS2A is a primer for CS2B, and you would not be doing CS2B. I can tell you that right now. Well, not my section anyway, right? Maybe you can do a section of CS2B elsewhere in a different college, maybe. Even if you're not committed. But if you're not really interested in computer science, if you're not really committed to C++ and programming, you should not enroll in CS2B. Certainly not my section of CS2B, right? Because 2B and 2C, they're really intended for transfer track students who intend to make computer science a significant part of their lives. And you will find out very soon in CS2B that not only does it take all of the knowledge in CS2A for granted, it just takes it for granted, right? I mean, we don't go back and review material about pointers and basic control structures in CS2B. And we have students, right? I mean, every quarter I have students who did not do a proper CS2A, meaning, for example, take my section of CS2A, they didn't, really apply themselves and get through to the end and figure out the different challenges. They just did it for a grade, maybe something on a transcript, and they come and do CS2B. They say, hey, I did my CS2A or an equivalent of CS2A at this college, this famous college out there that I learned there. And then they do my CS2B, and they find that they're really in deep water after the first couple of weeks. And then they say, well, it's only because I'm a little bit rusty and I'll come back to it later. And they procrastinate because they believe that they already know CS2A or C++ really well because they went to this flash college out there that gave them a solid backing, and they think they know everything. And so they put it off until later. So I just need 2 weeks to wrap up everything in CS2B. And maybe in week 6, they start doing everything, thinking they only need half the time as a regular student. And they find that's not the case. And then they end up blaming the system, blaming the class, blaming the course, saying this is the worst possible course I did because I'm getting no help at all for all the challenging problems I'm having. Well, and the reason students think they are not getting the help they need in CS2B, not in CS2A, right, is that they are really out of their depth, right? They're out of their depth in CS2B, no matter where, if they went to some, maybe they did CS50 at Harvard or something like that, right? But they didn't really do it with a commitment, and they do my CS2B, and they're out of their depth, right? They're going to be screwed in the first 6 weeks or so. And then they complain, if they complain, saying, well, it's because you may end up asking very basic questions, right? Basic questions in CS2B, but those questions will be answered, but in the right forum, right? You can't go into CS2B and ask CS2A level questions and hope to be helped, right? So that's why before you go to CS2B, you need to get really, really solid on CS2A with all the concepts, no matter where you learn it, right? No matter where you learn it, get really solid on the concepts and then get into CS2B. You'll find that CS2B is actually a pleasurable course to do because it gives you a great deal of satisfaction because you're going to be facing slightly higher level challenges, right? Not so high as in CS2C, right? But certainly much higher level than in CS2A. And the issue really is that most of these challenges you won't even be able to appreciate the depth of, right? So if you're not solid on CS2A, you may not even, well, there's a bunch of risks, right? One risk is that you may totally severely underestimate the difficulty of CS2B quests, or programs that you would write in CS2B, or you may not underestimate it, but you may, I don't know, overestimate your, no, it's like, um, yeah, I don't know what the two risks were, but anyway, certainly one underestimating is one of the risks, and when that happens, um, many people are in for a rude awakening, right? So you don't want a rude awakening; you want a gentle awakening, right? Someone comes and generally taps you on your shoulder. Here's your warm cup of coffee. Can you wake up, right? So that's the kind of awakening you'll get if you do CS2A properly, and see and ease into CS2A is to be, right? So, and now that we're approaching the end of the quarter, I think this is a good place to say that. All right. So it's like super duper important. So if you're not clear with any of these concepts in CS2A, it's important that you ask and get clarified. Right? You get clarifications and proceed. Okay. So let's see. Yes. Right. A lot of you are here. Um, I think some of the regulars are not here, so I believe that they're probably just on their way. So until they get here, let's talk about some of the concepts that we've covered already and that you find confusing today. What I'm hoping to do, um, if if you don't grab the reins and steer the vehicle or the conversation or the discussion elsewhere, this is what we're going to do. This is my backup plan. Okay, so I want to introduce a concept of pointers. Okay, which is like central to C++ and C, right? So I want to introduce the concept of pointers. And also at the same time, you remember I thought we'd talk about stacks, right? We'd talk about stacks. I just remembered that quest number 8 is actually a stack quest, right? You have to implement a stack of your own in quest number 8. It's very simple. It's in fact one of the easiest quests. Okay, for those of you who've mastered quest number 7. Or gotten past quest number 7, you'll find that quest 8, even though it says you got to implement a stack, is the easiest quest ever in CS. Well, not the ever, because Hello World is probably the easiest, but it is one of the easiest quests in CS2A. And you should not let that fool you or lull you into a false sense of security, because the quest number 9 makes up for that easiness, because it is a quest that will leverage pointers, and it's about linked lists, and it will be very hard compared to some of the other earlier quests. Okay, so you need to be really solid by the time you get to quest 9. So because we're going to implement, or you're going to implement a stack in quest number 8, I don't want to do a stack in exactly the same way as the quest requires. So I was thinking about this yesterday and thinking, well, what do I do today? Because, tomorrow, right? Yes, I was thinking yesterday, what do I do tomorrow? Because originally my plan was to implement a stack, but then I realized all of a sudden yesterday that, oh my gosh, we can't do a stack in class because that's your quest, right? And then you just copy and paste the code. You won't get any fulfillment out of it. So fortunately, I did discover a solution. We're still going to do a stack. We'll do a stack, but we'll do a different kind of stack. Okay, we'll do a stack that is based on linked nodes and pointers, and I think that's a better way to do it. Well, not a better way to do it. It's for our class, right? It's better because you're already going to be doing the other implementation in the quest. We might do the pointer-based implementation in class, which will also help me talk about pointers, right? Introduce the idea of pointers, and which is an important concept. Okay, it's like a super duper important concept, and we'll get to know that today. And now, and that point, and with pointers out of the way, next week is the last week of lectures for CS2A this quarter, which is a real pity because, given a chance, I would like to just continue with these classes all the way. Because, I'm only teaching 2 times a week, to CS2A 2 times a week, right? And the other classes are online. So most of the other time, I'm just looking at your code, reviewing other instructional material, doing administrative stuff, but mostly just looking at your code, right? And not anonymous code. I don't look at submission. Actually, I cannot look at any of your submissions that come in anonymously, right? Because um, I know that someone submitted, but I make sure not to save any of that code. So I can, but a significant number of you do submit non-anonymously, because, especially since we're coming to the end of the quarter, you'll be submitting points, your code with your student ID to get. So in those situations, I get a chance to look at your code and I review your code, not with a view to, identifying and telling you of bugs immediately. No, I never do that. But by looking at a lot of your code, many people, I get a really, really good feeling for the most common kinds of tripping points, right? I find that, hey, Bael's code in that submission, he had a vector index error, and 8 other people had the same kind of error. So maybe we'll talk more about that, or ask you, quiz you in during these classes, right? When I talk and I say, okay, what's going on here? Tell me, guys. When I do that, well, I usually say that when I have seen many people make an error in that area in the submissions you're making, right? So most of the time, other than the time when I'm talking to you in these lectures, that's what I'm doing, right? Other than, a few, very limited time when I'm basically doing my personal stuff and, doing non-technical stuff, right? That's what I'm doing. I'm looking at your code. I'm looking at the canvas and the participation, and when you say something on Reddit, I try to figure out why you said it and look at your code to say, and so on and so forth. That takes up a lot of my time, but fortunately, that time is not anchored to a particular clock position, right? Because that is all free form. I can do that anytime, right? I mean, after I don't watch TV these days, so in fact, my entertainment many times is basically just, I'm feeling really bored. Let me pull out my iPad and look at not iPad, look at some of the code, or the forum posts on Reddit to figure out what you guys are thinking. And because when you've got a puzzle, it's very interesting to see how different people solve that puzzle, right? So it's almost like a form of entertainment for many people, right? So that's what I'm doing, but it's free form, and I can do all of that even at 7 p.m., 8 p.m. I could be sitting down and catching up on these discussions. I don't have to do that during the day, which means that other than the actual lecture classes, I do have time to give you to talk about these things. It does make me very happy to talk about these technical matters, right? Don't think it's an imposition on me, or that I'm doing this because I'm paid to do that, or or you've paid me and I'm delivering a product, an instructional product to you. So that's, don't think of it that way. It's not an imposition. And I've told you this many times. I actually like this, I mean, once you, and you'll find this too, right? So when you start working and when you have people that you manage, and so on, you'll find that too. Or when you start teaching, once you know something, the only way you can get get a great deal of pleasure, right? You still get, awesome fulfillment out of it by using it, using what you know, but you also get a different kind of fulfillment out of the same thing by teaching it to other people, and then watching from the sidelines how they benefit from it, right? Because you just teach someone to do this, and then you can watch, right? You can watch, and they'll go away and do something cool with it, and then that also is really fun to watch, right? So and the really nice thing about that is that it is a repeatable pleasure, right? Because learning something is not a repeatable pleasure, right? So you learn something and you got a great deal of fulfillment out of it, and it's a one-time thing because you've learned it. You got to learn something else now, right? But teaching it is a repeatable pleasure because you can keep doing that again and again to right. Part of the reason why children are so fun, right? Is children are so fun to play with, as you may know, right? I'm sure you have relatives who have kids. Um, and they're fun to play with because they have so much to learn, and you teach them something and they go away and do that. When they do that, and all you need to do is when they do that for the first time, just look into their eyes, right? Look into their eyes, and the first time a child uh, or a newbie tries something out and it works, right? And it works, right? Not when it doesn't work, but when it works, and you look into their eyes, and then you can see physically their eyes just open wide. And so, wow, what the fuck just happened? It worked, right? And so when that happens, you can look at it, and you will feel. If not 100% of it, you'll feel at least 50% of that wonder that the other party had. So yeah, I don't know where we how we got started on that track, but yeah, okay, all right. Well, I think we should start. We have a fair number of students. Mm, oh, Daniel is not here. That's funny. He's been here every class so far. All right. Well, I'll check with him later. Um, yeah, most of the other regulars are here. Also, it's because it's Thanksgiving. Not because it's Thanksgiving, right? It's because it's the end of the quarter. We're coming up to the end of the quarter, and it's just one more week of classes in week 11. I really think I should thank you guys for the people that every person here, and I think that's entire. Most of you are here. Some of you are absent. Pass it on to them too, right? Who's been up here on stage and coded with the rest of us, you know, uh, voicing, verbally telling you what to do. Thank you so much, right? Especially for putting up with me, because I know that sometimes I'm very picky about certain things, right? And I say, do this and spaces and so on, and you unflinchingly, without complaining, right? And the person who's taken up the screen and coding on behalf of everybody else, just makes those changes without complaining and saying, hey, that's my style, I'm going to do it this way. No, even if it's your style, you do it in a different style on screen, because and that is an incredibly, thank you, yeah, you're welcome, right? That is an incredibly, and take it from me, right? Learning to program is only 50% of the skill, right? But learning to accept suggestions from other people, even though it may not be aligned with your own style, with your own way of doing things, saying, well, I'm going to do it that way because that person wants it. It's not going to kill me to do that, right? I'm going to do it. And that is the mark of a successful programmer, not a good programmer, because you can be a kick-ass rock star programmer locked up in your garage, right? And you can build the next Facebook in your garage, given enough time and a brilliance, which most of you have, right? All of us have, really, right? You can do that. And you can be a rock star programmer, and you can be turning out one mega hit over after another, right? But I don't think you will be a successful programmer in the real sense of the word, where meaning that you are contributing to the world of programming in a wholesome way, because then you're not really meshing with the community of programmers out there, computer scientists. You're not contributing your insight about how to approach problems, right? You share the solutions because you've locked yourself away in your room, you found the solution, you shared it. Yeah, okay, cool, right? So that's there, but you're not sharing how you came up with the solution or your way of thinking, right? This is your way of thinking. Once you've achieved the success you want, then it is not sufficient to share only your success. Okay, take that from me. right? Well, I'm not saying that you have to. It's not. It's income. You're obliged to do it. No, you're not obliged to do anything, right? You don't owe anybody anything, right? Suppose you're a master of programming and master of computer science. You're not obliged to share your knowledge with anyone. Okay, so I'm not saying that you should share your knowledge, but I'm just saying that if you want to realize the greater fulfillment of any art, really, right, is then you have to master it first, okay, in the confines of your home, that's fine, right, or your cave, okay, but after you've mastered it, you have to now show people not just what the solution is, right? You can't just lead the horse to the water, right? Or give a man a fish. What's the saying? Give a man a fish, you satisfy his hunger. But you teach the man to fish, you've taken care of his hunger forever, right? So it's not enough to just tell people what the solution is, but you got to get them to find the solution on their own. Because if you can't get them to find the solution on their own, what's the use, right? After I'm dead and gone, you can't find the solution. Well, you can, obviously. There's other brilliant people, right? But maybe there's a certain approach that I took to find a solution, which is, slightly different from other people or the extant solutions out there, which may coincidentally and serendipitously align 100% with how you think about the problem. Meaning that the way that I approach the problem is a perfect fit for you. Maybe not to 100,000 people out there, but it's a perfect fit for you. So if I didn't share how I came up with the solution, then that is lost, right? That is lost. Then I've only ended up benefiting like 25 people who were attending my class and took notes as to how to solve that particular problem, right? So in order to share the expertise, it's not just enough to share the solution, but also share how you came up with this. So getting people to think with you, I think that is a ticket, right? So get people, whether you're subordinates in your job and you're a manager and you have, right? Don't look at a solution. Don't look at a problem your subordinate is having and saying, okay, well, I'll think about it and get back to you with a solution. That is a bad manager, right? So a good manager says, let's think about the solution together. Let's try and figure it out so that your employee does not only get the solution, but they also get to know how to think about the problem. Because thinking about the problem in a particular way is a skill in itself. And that needs to be taught, because if you teach that, then you won't have that employee knocking on your door again saying, I got another problem, teach me. No, they'll find the solution themselves, which will frees up your mind to think about higher level problems, other problems. You can teach more, right? So that's the way to do it. And you always share these things. But I always say that, the way to share things is not by force, right? So if you know something, and if in your heart of hearts, you know that is a solution, right? Then that's how I think about it, right? I don't know how you think about it. If how do I know if someone really knows the solution? Someone says, I've found the way to be truly happy in life, right? I've found this the answer 42, right, to the question of the life, universe, and everything, right? And the answer is 42. Right? So someone says, I've got the answer to everything, to feel, so that you can never feel sad again. And then they knock on your door saying, well, I've got this, holy book or the truth that you need to listen to, and so on and so forth, right? And then, I generally ask, at least in my own mind, well, looks like that person is really desperate for me to accept what they're saying, right? They're desperate to convince me to follow what they're thinking, to believe what they do, right? So which kind of leads me to think that, well, obviously that means that they haven't found it. They're on the wrong path. They don't know the truth, right? Because if they know the truth, they wouldn't be dependent on other people to give them happiness, because the truth generates happiness intrinsically. Right? So if you go knocking on people's doors and saying, this is the truth, you have to believe it, you have to believe it, well, obviously that's not the truth, right? Because you need other people to believe it, right? So the real truth is something that, you would just do and say, hey, look, it just works for me. And then people will come knocking on your door and saying, well, and then people say, can I do this? Can I do this? Can I do this? Right? And then the real teacher I think the Buddha was like one of those people, right? So it doesn't say, no, don't do that. Don't do, no, it never says you have 100 different beliefs, 100 million, 33 million different beliefs. No, you should not believe. No, no, no. Anyone who believes anything other than what I say or what I believe is a blasphemer, or, needs to be killed. No, that means just I don't know what I'm talking about. I don't know what the truth is, right? So no, the right thing to say is, well, you believe these things, but is your belief going to kill you, right? If the belief is not going to kill you, then go ahead, do believe what you want, try it out, right? Try it out as much as you can. If it doesn't work, then come back and try out mine also, right? And see if it works, right? So that way is a much better way to teach, because that also indicates to these people that this guy actually knows the truth, right? So he knows what to do. And then, so that's the kind of teacher or a manager I would like everyone to be, you also, right? Eventually, maybe some of you are already in management positions in software jobs, but if you're not, you will be at some point. And that's the kind of manager to aspire to be. Is not to say that everybody should do things the way that I do it, no, but say do it the way you want to do it. But if you're not meeting success that way, I can take a look at what you're doing and say, well, maybe that's why it's not working, right? Maybe try this, right? And nudge you towards finding your own success, right? Not push you to find my success, right? And so that's where we want to go, right? That's where we want to go. And so again, thank you all so much for just putting up with me, right? So, like I say, every day after the class starts, we spend the first half an hour just waiting for all the students to come and join us. And while we're talking, mostly useless rubbish, right? And just to keep the airwaves occupied most of the time. And you're putting up with that, you're not complaining, and you're also participating. And so thank you so much. All right, I really wish that I get students like you every quarter, right? I mean, unfortunately, I've lucked out. I've had students like you in some of the previous quarters, but I hope that continues, right? I really hope that you guys are a fantastic bunch of students, right? I hope that I keep getting students like you, and I hope that you will continue to do my 2B and 2C and continue to stay in touch, right? After you finish CS2C, connect to me on LinkedIn or Facebook, stay in touch so I can, get updates. Saying, hey, Alexis just became the CEO of PepsiCo or something like that. I don't know, right? So, so I get those updates, and all that is really fulfillment for teachers and parents and well-wishers, right? So, all right. So, and again, right? So before we start talking about pointers and implementing stacks using pointers, two things. Number one, since a whole lot of you are here now, let me say that I am totally happy to give you a class, not a CS class, right? It can be a CS class. You can ask me questions about anything that we've covered so far is fine, pointers, control structures, or even data structures, data representation, anything you want. So also you can ask me questions about my personal life, right? What do I do? What do I do between the times of these classes? What do I do? What did I do yesterday? What do I believe? Any damn thing not to do with computer science. Ask me anything, AMA, right? Ask me any damn thing. I can do that on Thursday. Because it's an unofficial lecture, I don't have to talk about computer science or C++, but I'm happy to talk about that, right? And in fact, I'd be super happy to talk about C++. If you guys want me to talk about C++ on Thursday, I'm happy to do that. So take a poll amongst yourself, and if more than 2 people, right, want a class, not a class, right, want a session on Thursday morning, does not have to be at 8 a.m., right? Maybe 9 a.m., that's fine, right? Because if you want a class anytime on Thursday before 3 p.m., right? 3 p.m. I got to go somewhere, right? So before 3 p.m. on Thursday, if you want a class, just let me know. Not a class, a session where you can ask me any damn thing about my personal life even, right? Let me know. I'm happy to do that. And hopefully we'll wrap up this quarter. We'll wrap up this quarter in next week, right? Finals really is all up to you, right? We'll wrap up with a really solid understanding of all the fundamentals, right? All the fundamentals, because from now on, I think from next week, you shouldn't really be thinking about control structures and all these basic things like data types and so on, right? You should be thinking about the finished product in your mind, right? Like this game that we did last class, right? This game we did, and we're saying, I want to do this. What do I do, right? Bam, 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 bam. You're just thinking about, the logic and the things you put together, like Lego pieces. When you want to build a citadel, you say, well, I want to get these two rectangular blocks here, and there's a circular spire here, and so on. So that's in your mind already, right? So you need to be thinking at a higher level, right? And not assembling the individual pieces, right? So you have this entire performance. You're thinking about the entire performance, right? Not the 10 steps that's going to take you from this position, this post to that post. No, right? So because you've got all of that already in your mind, and you're thinking through the entire story. So you're not thinking about the top layer, right? So that's how it is, right? Any performance, any story, any book, any movie, right? It's multiple layers. And then in the beginning, everybody's looking at the top layer, right? Because that's what you can look at, right? So when you can look through the top layer, then you look at the lower layers, and then greater and greater meaning, right? More and more, the profound intricacies of C++, right? I think it's arcane features, right? I don't know. Right? So all these incredibly useful things will start bubbling up, right? And getting closer and closer as you descend past the top layer. And that's where we need to be. Okay, so before we start talking about pointers, if you have any questions about previous things we've talked about, any other issues that you would like to clarify, let me know. My expectation is that no later than 8:45. Okay, it's 8:39 now, so we have 6 minutes. No later than 8:45, I start talking about pointers, and then maybe at 9 o'clock we implement a stack using pointers, right? And it's going to be an interesting exercise, I think. Well, I haven't yet. Well, I mean, I've implemented it a very long time ago, not just in the past. It's not awful. It's not an awful long piece of code. I mean, I think if you want to implement a stack using pointers, we could do it in less than 40 or 50 lines, right? It's that much, right? It'll fit inside a YouTube window, all of that code. I think so. Yeah, I think so. I think it should be possible, right? And in fact, a pointer-based implementation of stacks is actually easier in many ways than an array-based, which you're going to do in quest number 8. So it's going to be easy, and we'll do that. Okay. But in order to do that, you need to get a solid grasp of pointers, which we'll do at 8:45. So is there anything else that you would like me to address? Any concept that you are a little loose on, right? And as far as last week's game goes, there's a sorting game. I would really like it. I mean, I would like it if one of you can turn that into a web-based game. But if not, at least polish it up and post it in Reddit. Nobody even shared it on Reddit, right? And many of you had a hand in developing it, right? So I think 3 or 4 of you put that together, and not one of you shared it on Reddit. So I think what you should do is take that code and share it on Reddit, and put a comment on the top of your code that you post on Reddit saying this program was developed by Rizzo and Bile. I don't know who else was working on it. I've actually forgotten. But comment saying developed by or created by, written by, and put your names and post it on Reddit. Okay, post it on Reddit. And also this other thing, right? This is a time when I'm getting emails from some of my senior students in 2C asking for college recommendations and so on, right? Starting this year, I have stopped writing comparative recommendations, right? Comparative meaning I won't reference your grade, saying, oh, this student was an A+ student, and so on and so forth. I find that is totally useless and is probably even misleading, right? Because who knows, right? Just because you got an A+ does not mean that you're a solid programmer, right? So because programming, as we saw before, is not just about programming. It's about understanding the concept and being able to explain that concept to other people in a way, because when people look at your explanation, they'll know how much you understood it, right? So that's why I keep pushing you guys to start contributing on the Reddit forum, because when it comes time in 2 quarters, you remember, right? And take it from me, you think that CS2C is 2 quarters away, is a long time away. No, 15 years will just fly in the blink of an eye. right? So, and this is we're talking about just 2 quarters here. Very quickly, before you know it, you will be doing your CS2C or 2A. You will be asking me for recommendations. Well, first of all, I don't write recommendations, college recommendations, or any recommendations for students who haven't done 2B with me, right? So, because 2A is an introductory course, how do I know if you're a C++ person or not, right? So you got to do 2B with me if you want a college recommendation, if you want me to write one. And also, you got to keep in mind that I don't write a comparative recommendation saying, oh, this student was the best in class or top 10%. No, some of these colleges, right, even some of these MIT, and so they require, maybe not the right? They ask, was the student in the top 10%, top 5%, right? I typically say, no, I don't answer these questions, right? I don't answer these questions. The only things I do is that, this student was absolutely fantastic in my section. They helped, they not only did all of the work required in an excellent way according to my assessment, but they also went out of their way to help other students by explaining concepts to them. And I'm not going to tell you how well they did it. You can see for yourself. Here's their Reddit handle. Okay, so I would send your Reddit handle to college admissions officers. So when you contribute on these forums, keep that in mind, right? Start right away, because you got to start building it up, right? So you can't, when you start going, you can, say, I'm going to start working now. I'm going to create a resume, and you don't have anything to put in the resume. It's not going to work, right? So right now you're preparing to work by preparing for employment down the line by building up your resume, right? You're building up your resume saying, oh, I did this course. I worked at XYZ. I worked at, ABC, and so on and so forth. You're building up your resume, right? And that's exactly how you should approach your contribution on these public forums, right? In 2 years' time, you're going to be starting to look for a job. I start building up your online profile right away, right? Contribute on Reddit, so that in 2 years' time, people, I can just point, or they'll just, your employers will just Google you, right? And it'll say, hey, here is, I was Googling Bile, I still can't pronounce your last name, all right? Flavio. No, Gaomeng. Okay, Gaomeng Luo, right? So easier to pronounce. Right? So I was Googling Gaomeng's name, and, I found, all these contributions he made on Reddit, and check it out, man. This person really knows C++. We need to get them to come here and implement that, sorting technique that they came up with, all right, or something like that. So start building up your profile, building up your online portfolio. This is your portfolio, right? As you enroll in art classes, you're expected to have a portfolio. By the time you enroll in college for art or music or dance, you need to have a portfolio, right? So in computer science, this is your portfolio. I'm giving you an opportunity, right? I'm not giving you an opportunity. You have an opportunity, right? But I'm helping you in your opportunity by making sure that your portfolio is clean, right? Because if you, let's say that after you finish this course, you start creating a portfolio on your own, then you're on your own, right? You may say bad things and you may not notice it, and someone else could notice it, and that might ruin your chances of getting a job, right? But here you have me and your tutors and other students looking at your posts, and we're all happy to polish up your online profile. If you say something nasty or bad, we can go and clean it up for you, and so that you'll know what needs to be there, and also learn in the process. So that's the whole idea behind these forums. You got to go and contribute. And so these code the programs you're writing in class, they are great candidates for you to share online. Maybe not on Stack Overflow, because they're not right talking about specific issues like this, but on Reddit, where we actually have an opportunity for you to post the code and share it, right? So go ahead and do that, and start building up your profile and portfolio, and we're all here to help you. Okay, is there anything else that you want me to talk about? All right. So if not, we will talk about pointers, right? So pointers. By the way, I want to know who is listening and who is not, and who is basically taken off. To be honest, I actually don't know. I know that so I am talking to a whole bunch of you, and you are listening. But I also know, in general, maybe not in this class, right? A great deal, maybe even 90% of what I say basically falls on deaf ears, because because the many people may not have the background or the context, or the prerequisite knowledge to assimilate what I'm saying, and so it just goes over the top, and they lose it. And I don't know. I know most of you here are listening to me, and you find it useful. Just so let's make this also your roll call here. So let me know if you're here and listening by typing yes. Yeah, okay. And then I'll start talking about pointers, because pointers is a very useful and important concept that everybody needs to know, right? Not just the guys who are present here. Everybody needs to know about pointers. Yes, thank you. Thank you. So, okay, there's a, um, thank you. All right. So can someone tell me what a pointer is? We've gone over this a few times in the past, not really in any great depth, but we'll start with what you think a pointer is, and then we'll take it from there. Yeah. And let's say at 9:15 we'll start coding the stack. Okay, 9:15. Yeah, a pointer is basically just a memory address, right? So my room on campus, my office on campus is room 4413. I forgot. It's been so long. 4413, I think. Right. So the that is a pointer. So the 4413 is a pointer to me, not me. Yes. Yes. So anytime you're confused about a pointer, just think of me and my room. Okay. So the value of me is me. Okay, that's my value. What is inside of the room? That's me. That's my value. That's Anand is that X, right? That is me, Anand. So if Anand is a variable, right, which human, right? So Anand is an enumerated variable for humans, right? So 4 billion enumerations, right? So that's the specific variable, but 4413 is also a variable because there's many rooms, right? So this is a 4413, 4429, 4129. So many rooms. So, and each room has a different faculty member in it. So, um, so that is itself a variable, isn't it? So 4413 could be a variable because I could say room number is a variable. Say if room number equals 4413, then the contents of the room is Anand. Right? If room number is 4209, I don't know. This is 4209. I don't know. Right? So if room number equals 4219, the contents of that room is Rosa. Right? I don't know what Rosa's room number is. I picked up Rosa because she and I exchanged rooms. Yeah, okay. All right. So by just changing the value of the room number, I'm able to get to different contents. Yes. So yeah, that itself. So what would I call that variable? The variable that holds a room number, not the contents of the room number. So that is a pointer. Okay, so and in terms of the computer, we're not talking about room numbers. We're actually talking about room numbers for those bytes, which are basically memory locations. And this is 40 billion, like Augie said, which is a huge number of memory locations, depending on how much memory you have on your device. And each location up to 40 billion, 100 billion, I don't know how many bytes you have, right? Each one is a location that can be stored in a pointer. And why are pointers useful? All right, why are pointers useful in C++? So pointers are useful in C++ because the operating system gives you the ability to access what is called a heap memory, right? So when your program starts up, it gets two kinds of memory, right? One is called the stack memory, which you can call the local memory just given to your program, right? And on the stack, all the local variables will go, right? And I think we talked about this before, because the stack model is last in, first out. This is, when you, after a party, when people come and stack their, dinner plates next to the sink or somewhere, right? One on top of another. It's a stack of plates. Now, when you want to remove something from the stack, you can't just go and pull the bottom one or a middle plate off, and it'll topple the pile over. So there's only one place where you can access the stack, and it's the top. Right? And what can you access at the top? You can't access the first thing that was pushed. You can only access the last thing that was pushed, right? So a stack is a data structure, something where you can access the last item that was put on it, always, right? That was put on it and not taken off, right? So it's called last in, first out. So it's called LIFO. LIFO, right? So can someone tell me if there is an analogous data structure where instead of the last thing that that was put in coming out first, I want the first thing that was put in come out first, right? So in other words, I want to put things in, but I want things to come out in the order they were pushed in, right? Yeah, it's a queue, right? It's a queue. Every time it's in America, we call them lines, right? And in supermarkets and grocery stores, lines, because a line, you can jump a line, right? You got to go in the order in which you entered the line. So the fifth person gets treated on the fifth turn. So that's a queue. And a queue is called a first in, first out data structure, right? So it's a FIFO. Yeah, thank you, Momo, right? A queue is a FIFO and a stack is a LIFO. A LIFO is last in, first out. Now, a LIFO is very, very useful in programming, all the way down to the level of even a FIFO is, right? So, but a LIFO also has uses, significant uses, even at the level of an operating system. When we talked about functions, did we talk about how stacks are used when functions are called? What is a role played by a stack in the function call, in when a function is called by another function? Did we talk about that at all? All right, so Georgia says no, right? So what it says here is, here's an analogy I used in the past, okay, in class, and students actually liked it. So let's, run with it until it completely dries out and there's no more fun left in it, right? So let's say I'm teaching a class in C++, right? It's C++, and I'm in the middle of a class, right? And someone just runs in through my door and says, "Hey, Anand, I just saw a burglar in your room, right? As a burglar in your office, riffling through the midterm questions or something like that." Okay, so what do I do at that point? So at that point, I have to. It's high priority, right? It's an interrupt. It's a high priority. So, but I can't. What I do is, because I'm teaching you guys, I have to take a break and say, hang on, guys, don't go away, because I'm going to go take a momentary break and go to my office. I got to run to my office, shoot the burglar, and then I'll come back here, right? And I'll continue to teach C++, right? So I need to go shoot the burglar, come back, and then continue to teach C++, right? So I'm doing that. All of a sudden I get a notification. I go to my office, shoot the burglar, come back, right? And continue. But there's a couple of very important things that happen here, subtleties that are important to know, right? One of the most important things is that when the person comes in and notifies me that there's a burglar in my office, I need to switch my mindset to because right now I'm in C++ teaching mode, right? And I'm teaching C++. So when I've been told there's a burglar in my office, right, I need to switch from C++ teaching C++ teaching mindset to burglar shooting mindset, right? So I need to do that immediately. Or else, if I'm still in my C++ teaching mindset, what would I do? I'll go to my office, and instead of shooting the burglar, I'm going to teach him C++, and then he'll shoot himself, right? Okay, so yeah, that might be a much better way to do it, right? Or maybe he'll just say, I'm not going to burgle anymore. Now that I know C++, I can go and conquer the world with C++. It's much easier, and right? So I need to do that. I need to swap my head, right? I can't have any lingering notions that I'm in C++ world. I got to completely give up C++ and go to a completely different mode, right? So there. Another thing I need to do, right? I can't, when I've swapped my mindset, I'm not a C++ teacher anymore. I'm a guy with a gun in my hand, right? It's a bad analogy, right? We're talking about violence here, but forget it. Maybe it's a toy gun, right? So I got a gun in my hand and I'm in a shooting mode now. I can't afford to be in class teaching C++, right? You guys are going to get the fright of your life and run out of here, right? So, so I can't afford to be in a gunner down mode in class, right? So that's really bad. So what I need to do is, after I've switched my mode, I need to make sure that you guys are not alarmed by the prospect. Okay, so in the process of switching my mode, I need to basically wave my hand over you guys and put you all into a deep cryogenic sleep. Okay, so that you guys have no idea what the hell happened, right? So in fact, if you that just happened like a couple of seconds ago. Did you know? All right. So and the reason you don't know is because just before I did that, I just did that, and you forgot everything and went into a sleep. I went to my office, took care of the burglar, right? Taught him C++, came back here, and then waved my hand in the other direction, and then you loaded your old context back, and you came out of your cryo sleep, and you didn't know anything. You didn't know that I disappeared. Nothing, right? Everything happened seamlessly, as though it was, right? So that happened. Now, so it's very important that I save the state of the class. I save it. And so the other important thing is when I come back from after taking care of the burglar, I need to give up that defensive offensive mindset, and got to put the toy gun away and things like that, and get back into my C++. No, I got to swap. I got to swap again, right? And then get back into C++. So there's a bunch of things that need to happen here. So I need to first of all save my current mindset here, because if I don't save it and just overwrite it with burglar handling mode, then when I come back, I don't know, how do I get back to the old state, because it's lost, it's overridden, right? So I can't overwrite it. I got to take my current mind and save it somewhere. I got to save it somewhere, right? I save it and then load my new module, right? And then I do that stuff and come back and offload that module and load back the core, right? That was dumped from my head, so that I'm back. So that very important thing happened, so that when I come back, I can resume where I left off. Okay, now here's the intricacy here. What happens if, while I'm in the process of handling the burger, right? I've gone into my room. Hey, what are you doing? Riffling through my exam questions. Yeah, here's a guy. I'm going to point. And then I'm just about to pull the trigger, and someone knocks on my door and says, "Hey, I'm my daughter wants to be picked up from school," or something like that. Some super duper high priority thing, right? Even more important than shooting the burglar. So what do I do, right? So at that point, I can't, take care of the burglar then, which is a high priority. So I got to tell the burglar, "Hey, burglar, don't go away, okay? Just stay right there, because I got to go and drop my, pick up my daughter, but I'll come back and shoot you, okay? So don't go away, just stay right there, right?" Of course, I can't tell him that, because he's not going to stick around if I tell him that. So in fact, I'll do the same thing with the burglar, right? So I'll wave my hand and put the burglar into cryo sleep as well, right? So he's also stuck there, and then I go take care of that task, and then I come back. But when I come back, I need to remember to load the right module, right? Because first I had the module in my head for teaching C++, which I saved here. Then I loaded the module for handling a burglar. That also I saved, because I had to load a new module to pick up my daughter, right? So I did that. So when I come back, I got to load my modules back in the right order, right? So when I come back there, I can't load the C++ module. I got to load that, right? And then after I'm done with that, so now you can see where the stack comes into the picture, because it's always, what happens when I'm dropping my daughter, someone else has another even higher priority task, even though, such a thing doesn't exist, right? So I got to follow things back in the exact same track that I took going there, right? So everything, the last in, first out. So every time I do something, when I got to do something else, I got to do that, come back and take care of the most recent thing I left, right? So it's last thing I was doing is the first thing I resume again, right? So last in, first out is the model that the operating system uses when it comes to handling function calls. So when a function call happens, what it will do is it will take the context. This is the context, right? And most of what I'm saying now is basically part of computer architecture. So it doesn't have a direct bearing on your CS2A, but I think it will be useful for you, except more flexible and for data. Oh, wait, no, that would be, I don't know. There's another independent conversation happening there, okay, in the chat window. So sorry, I can't participate there. What was I saying? Yeah. So I don't know what I was saying. Yeah, okay. So last in, first out. So so it's a stack. So I store everything, and I also store one other very important thing on the stack, right? I take my mental state, push it on a stack, store it on a stack, and I store one more thing. I also store on the stack the place where I should come back to after I've taken care of that little task, right? So because if I didn't know, right? So if let's say I'm lecturing in room number 5607, and then I need to run to my office, 413 and do something, right? After I've taken care of the burglar, I need to know where to go back, right? Which room was I teaching in? Because I've forgotten everything, right? So even 5607 needs to be saved somewhere, and it needs to be saved in the same context. So all of that is a package. It's called a context with the return address. The return address is 5607, right? So where I need to get back to after I've done the small routine. So all of that is pushed on the stack. So every time a function call happens, the context of your current execution is pushed on the stack, right? And then a new context is loaded. You go and execute the function, right? When the function is done, you come back and then pop the stack, right? Take what you pushed on the stack, the topmost item, and load it into your head, right? And then you can continue. So does that cycle make sense? Right now, if in the process of handling the burglar, that other higher priority task came in, so I take the context at that time, which is how to handle a burglar, right, and push that on stack on top of the existing frame, right? The current context frame is to do with teaching C++. On top of that, I have the stack frame, the bunch of variables that say, this is the context for handling a burglar, right? And then it goes elsewhere when I pop, off the stack after having handled that other task. I know that, oh, now my mindset is in burglar handling mode, right? So I do that, and then after doing that, I pop one more, and then under the burglar handling frame, what is it? We have the C++. So as long as I do it in the exact same reverse order, then I'm guaranteed that that continuity is guaranteed, right? So it will work out nicely. Does that make sense to you? How a stack works in a function call? Because if it does, what we'll do is, we'll leave it at that, and then we're going to start implementing pointers, right? In 15 minutes, we'll start implementing the code. We'll talk about pointers for a little bit, and then use pointers to implement a stack, right? So we'll, in fact, implement a stack using pointers, and so it'll be, a double exposure for you. Okay, so now is the time you would chime in the chat window saying that if things are clear and we can proceed or not. Okay. So do you know how? Yeah, thank you, Sumit. Yeah. So that's how a stack works. Things are clear. Thank you. All right. So yeah. So right. Okay. So can we talk? Can we start talking about pointers again? Yeah. Because we had a brief diversion to into stacks. All right, so pointers, again, yeah, memory locations, and they are useful because the reason we started talking about stacks is because a program gets a stack when you execute, when it starts running, but it also gets a whole heap of memory. It's actually called a heap, right? And that is only limited by the amount of memory you actually physically have on your device, right? On your phone, if you have 64 gigabytes, 256 gigabytes of RAM, right? So addressable memory, all of that is available to your program when it runs, except not in the stack. So you can at any time you can ask the operating system to say, hey, give me 2 bytes. As little as 1 byte. You can ask the operating system as little as 1 byte, and it'll give it to you, right? And that byte comes not from the stack, but comes from the heap memory. Is 256 gigabytes of memory. It'll take a byte and give it to you, right? But it won't give you that specific the contents of the byte. Instead, because it gives the content of the byte, it's useless really. What do you do, right? It's like a variable. So when you get the value from the operating system for allocated storage, right? So you're saying, give me a byte to store integers. That's exactly what you get. The operating system will say, all right, I've given you a byte, and that byte is located at this address. So it'll say, 4 billion and 7, right? Your byte is at position 4 billion and 7. All right, so it'll give you the number 4 billion and 7. But when you ask for a byte, that 4 billion and 7 is not the value you're after. 4 billion and 7 is the location. You can go to memory, in memory, to find the value that you want. Okay, so that's how you get the pointer. So and the reason that pointers are important is because you can pretty much get unlimited amounts of memory. Unlimited meaning as much as the device has, right? By requesting it from the operating system, as much memory as it's able to give you, it'll give you, but it'll only give you pointers. Now, well, that is the access side of the things, the access side of the picture. Meaning, okay, pointers make it easy for us to use new and get memory from the operating system. But why else? Why would you need it anyway? Wait. So here is a very good reason for you to for motivation for pointers, right? So when your program starts up, you get some dedicated memory that nobody else is allowed to request or write into. That's your stack memory, right? It's your process memory. And obviously, when your program starts up, the operating system cannot say, well, this device has 64 gigabytes of memory. This program just started up, and I have 64 gigabytes free. What am I doing? I give that person the entire 64 gigabytes. No, it doesn't do it, right? Because if someone else comes after that and asks for memory, they won't be able to run their program until you're done. Right, so you won't get the whole memory. So for your stack anyway, so you typically get, I don't know, you can test it out, right? At some point you can test it out. 100 megabytes, maybe 100 megabytes or 10 megabytes. I think it's 100 megabytes, right? Every program gets 100 megabytes, nowhere compared to the 64 gigabytes of memory that your system actually has, right? So that's all the memory you have. And so suppose you wanted to create a massive data structure, right? Of a sequential data structure. Sequential meaning each item has a well-defined successor, next item, right? So what is one such data structure, right? So tell me a data structure in which you have an ordering, a sequential ordering, right? So built into the data structure itself, meaning that if I give you any one component of the data structure, you can tell me that this component has a unique, well, it does not have to be a unique one, right? It has a predecessor and a successor. This is the predecessor. This is any item I give you, you can immediately say these are the predecessors, these are the successors, right? So let's say one predecessor, one successor, right? So for any item, which it'll have one successor and one predecessor, well-defined, unique, right? Unique. So can you tell me a data structure that you already know that gives you that facility? So take a stab at it, okay? So tell me a data structure that has the facility or a feature in which you can access each item and its predecessor, and what the predecessor is and the successor is. We play with that data structure every time. Most of the time in the last few lectures, we've played with the data structures like that. An array, yes, thank you, Augie, okay? An array is a data structure in which every item has a well-defined predecessor and a successor. Well, except the first item, which does not have a predecessor, and the last item does not have a successor, right? Incredibly, there is an array. It's called a circular array, which you can build, right? Which you will build, in fact, in CS2B, you will build a data structure like that, in which every item, including the first and the last, right, have a predecessor and a successor, right? So you define an array such that the first item has the last item as its predecessor. And yeah, so if an array has only one member, that member is simultaneously the member, its predecessor, and its successor. Because you are at that item and you want to, and yeah, it's a circular array with only one item. What's the next item, right? Go back, it's the same item. What's the previous item? It's the same item. So if the array has only one, yeah, okay. So you can, even if it has 0 items, it works, right? It's the concept works from 0 to infinity. So an array is one such. But if you have only 100 megabytes of memory in your stack, technically, right? So in theory, it should work, right? Even if you had 0, the data structure itself is consistent, right? If there is an item, if the array, if the container has items, every element has a unique predecessor and a successor. If there are 0 items in the container, there are no items, right? So if there was an item, it would have yeah, exactly. You would not have any object to refer to. Yes, exactly. That's right. Okay. So yeah. So the concept is consistent, internally consistent. Okay. So what was I talking about? Yeah. So if you only had 100 megabytes, and you can only have 100 million items in your array of bytes, right? Right. If you want an array of bytes, you only have 100 million items in your array. But sometimes you want to have an array of much more items, right? And also imagine, right? Suppose you're maybe I should use my drawing board here. Hang on. So let me talk about while I'm doing. So suppose your memory is fragmented, right? So let's assume your memory is fragmented. Next time, maybe I should just have this ready before I start the class. Okay. Canvas. Okay. All right. What was I saying? Yeah. So you want many more items. What was I saying? I've lost track. Yeah, suppose you want a lot, you want, yeah, gaps, yeah. So I was talking about memory that is fragmented, okay? Your memory, if your memory is fragmented, I'm going to share my iPad screen, okay? So Photial Zoom, and um, okay. Okay, can call using internet audio, and I. We had this problem before. Let me join the meeting, and um, uh, that's why I should have done this before class started. Okay, let me join this now. Join. Okay, now what do I need to do to make sure it doesn't oh, I can actually just say I don't want to join audio on the iPhone, on the iPad. That's it's as simple as that. Okay, cool. All right, so let me go share content, whiteboard. Can you guys see my whiteboard? Can you see my whiteboard?
Yes.
Okay, great. So let's say that this is my memory. Okay, 100 megabytes. Okay, 100 megabytes of memory, and even though I have 100 megabytes, let's say some odd programs, right? Maybe Lex wrote a program that's running here, okay, and it's taken up this space, okay. Maybe BIOS program is running here, okay, and maybe someone else has got a 1 byte allocated, right? And this is also used up. Now I want, let's say, some memory. I want an array or a sequential container that is this big, all right, that big. Now, there's no way I can get that using the current memory configuration unless, because, there's no unbroken, so let's say that's 80 megabytes, okay, that's 80 megabytes. Okay, I cannot get 80 contiguous bytes of memory. But I can get 80 contiguous bytes if I rearrange, shuffle things around and say, move all of the used up blocks to one place so that I can free up contiguous blocks and use that. Yeah, it's a bit of a pain to do that, right? And also, it's not the best possible way to get memory because really there's not 100 megabytes, but actually, gigabytes of memory here, right? Gigabytes of memory that is not in the stack. What I need is to get my 80 megabytes out here, right? Where there's a lot of empty space, right? I don't have to worry about, broken up sequences of bytes. So that's where I need memory. So if I use pointers, I can get memory from here and not just from the stack. So it actually makes it possible. Now, even better is the memory does not even have to be contiguous, because if all I'm interested in is if I'm not interested in constant time access to each element, but I'm just interested in getting that sequence, right? For every element, I just need to get the next element or the previous element. That's all I need, right? I don't want it to be like an array. Then I can do something even cooler. I can actually say that this is one of my elements, okay? In each element, there's only one element, right? There's only 24 bytes. Let's say it's let's say it's 80 bytes, 80 bytes, right? Not 80 million bytes, 80 megabytes. No, it's 80 bytes. Okay, it's 80 bytes. This is just one element. This is one element, right? Now I need a million of those, right? I need a million elements because, in my container, I had a million of those, but I've only got one here. So what I do is I'll introduce an overhead, a small overhead of 4 bytes, okay? And in this case, it's 4 bytes because a pointer is really 4 bytes on most architectures. Is that still true? It's 4 billion, right? So the 4 bytes, you can only get 4 billion addressable locations. And 4 billion is 4 gigabytes. Yeah, so obviously with bigger machines which have addressable space up to 256 gigabytes and all, I think pointers also have to be wider, like 8-byte pointers, right? But we'll consider 4-byte pointers for now, right? So I got one, and I'm going to inside of each of my elements, I'm going to stick in a 4 extra bytes, 4 extra bytes here. That's my overhead. And in this 4 extra bytes, I'm just going to put a pointer to the next element, which may not be here. It may not be, it's not here. The next element is not immediately under. It may be somewhere else in memory, completely some weird place, right? This, right? But this pointer here points to that element. Okay, so I'll call this my next element, right? So maybe I have a variable called next, okay, which is a pointer. And a pointer points to the next element here. And this guy also has a next element that points to some other element here, okay? And that guy has an element here, and so on and so forth. Now you can easily see how, well, there's two things become very obvious right here, okay? The first thing is that now you literally have unlimited memory, because you don't need to all the memory to be contiguous, because your application does not require that. It's okay if the elements are all in different places, as long as each element tells you where the next element is, right? So by using a next pointer, you tell inside of each element, you have a next pointer that says, okay, when you're done with me, here's your ticket, go to the next element, right? When you're done with me, go, that's your next element. So you can keep moving. So you store all of those and use those pointers. Yeah, well, I had a message come up on my screen, but it didn't come up on the screen. Okay, I think. Okay, all right. So that way, do you see how now I can have a chain of cells, right? Which in an array were right under each other, one next to another, right? But now I have a chain that are in different places, scattered all over memory, just at one points to another. Now, people talk about spaghetti code, code that is really hard to debug because, it goes all over the place from here, right? If you think that debugging spaghetti code is a pain, right? Wait till you get to debugging spaghetti pointers, right? Spaghetti pointers, at least code you can see, right? Code you can see. Even if it's spaghetti code, sometimes you can clean it up, you can see it. With pointers, if you have pointers, you can see already, right? I was drawing this on this whiteboard, and already I've got these crisscross lines and, all over the place. Imagine if you had a data structure, a linked data structure in memory, which had like 80 billion cells like this, and each cell was pointing to another cell, and they're all pointing, right? So that is spaghetti pointers. When you get to when you build a data structure like that, you better be really solid on or know what you're doing, because there's absolutely no way you can debug that easily, right? In fact, when you want to debug pointer code, you cannot examine it and debug it. Most of the time you'll have to use diagnostic messages, right, in your code to say, well, this is where I am, this is why, my pointer, my next pointer shows this and my previous pointer shows that. Okay, so you have to print things out which tell you what your immediate environment is in your memory, right? So I'm here, and this is what it looks like around me, right? Now I've taken the next pointer, gone here. Now this is what it looks like around me. So you got to get these limited, tunnel vision spectacles, right? And you're only looking immediately around you in each of these locations, and you have to figure out. You got to figure out if the logic is working just by looking at tiny spots here and there with a tunnel vision lens. Does that make sense? Okay, so that's why pointers are introduced at the very end of CS2A. And I know lots of programmers who say, well, I know C++, I'm going to get into pointers, and they start programming with pointers very early on, right? And I think I don't know. I think it's really risky, because if you can get lost in code, right, in the forest of code, and find it hard to debug, you can imagine how much harder it's going to be to get lost in not just a forest, but a universe, right? You're in a universe of pointers out there, and you're lost in there. And furthermore, you can't even look at all of it. You can only look at, your torch can only illuminate like 100-meter radius around you, right? But you're in the universe that is, 100 million, billion, trillion, infinite light years big, and you're in a location which only has light for a, certain radius around you. And you got to figure out how to set this universe right. How do I fix this massive universe, this galaxy? How do I fix this galaxy by only looking at 1 cubic meter at a time? Right? And you cannot. The truth of the matter is you cannot do that unless you get, unless you develop, unless you you figure out
the underlying structure of the galaxy, right? Once you figure out the underlying structure, you don't need to look at everything, right? Because once you figure out the structure, everything else becomes predictable, right? You don't have to look at it to know what's going on, because you know the laws of science, the law, the physics of it. You can just figure it out. So if someone says, if suppose you know all of physics, assuming that such a thing is possible, suppose you know, right? And suppose it's a deterministic universe, right? Let's forget about acausal, okay, right? It's a deterministic universe, which means that everything happens according to preconditions and physical laws, and every single physical law, right? Theoretically, right? So suppose you know that, uh, and where was I going with that? Yeah, so then you don't have to know the entire, then you don't have to have the power, your eyesight, right? Your physical eyes don't have to be powerful enough to see the entire universe, right? Because your mental eye is now gotten so strong that without having to see the rest of the universe, if someone asks you, hey, what is currently happening in planet X, orbiting star 495 in the Andromeda galaxy, all right? So someone asks you that, if you know all of physics and all, and they give you all the preconditions, you can say, well, I think right now the temperature on that planet is 45 degrees, and it's drizzling slightly, 2 inches of rain, right? You can make these amazingly accurate predictions about a place that you can't even see, right? And so it is the equivalent of having universal vision, right? Because you know how it works. Once you know how it works, you have universal vision, because you can basically, without seeing it, you can basically simulate it 100%. With 100% fidelity, you can simulate it in your head and say, well, according to everything that is in the laws of science and everything, right? This is exactly what should be happening right now at this moment in that planet, okay? Far away, which we can't even reach right now. This is what should be happening, because that's what the law dictates, right? So now, because you can play it out in your head, you basically see it. Anything you want to see, you can see in your head, right? So your physical eyesight does not get you there, but your mental eye gets you there. So theoretically, right? So that way you can, so that's how you handle massive problems in computer science, MapReduce and things like that, right? So you have these problems that are going to take the computing power of all of the machines on Earth, right? Every single phone, right? Suppose you come up with an incredible algorithm to sequence multiple genomes, or in a certain way, or some inherently hard problem that you manage to solve. Except that in order to solve that, you need every single iPhone, every single iPad, every single computer out on Earth to be giving you 10 cycles every hour, right? Which people don't even notice, right? People have screen. I think Stanford at one point, the genetics lab had a screensaver. I think they called it folding and screensaver, right? And it was basically a screensaver. It gives you nice little genomes floating around on your screen, but in the background, what it was doing was using your computer to sequence some chunks of genes and send it back to Stanford, right? So they basically took up the sequencing problem, chopped it up into billions of tiny problems, and then sent them all to these computers all over the world, right? And they're all, not using up your computer when you want to use it, only when you don't use it, right? Because the screensaver is running. Then your screensaver, it solves a problem. A small part of the problem sends a solution back, right? That's how you crack these enormous problems, big problems that defy small computers. That's how you do it. And that's how you solve these big pointer-based bugs in your code, is not by, looking at every place. It is impossible, right? You can't look at every single place and solve a pointer-based bug, right? You got to think, go back, right? Draw yourself back, get the high level view of what the hell is going on there. What is it trying to accomplish, right? Get the picture in your head and try to figure out what's going on. Once you know what it's doing, then you will know, right? Without actually physically looking at each pointer location, you'll know, well, if that's what is supposed to happen in that location, right? Because the value is there. And so you figure it out. And that is the way you tackle a big, that's the way I do it anyway, right? And it has worked for me. And try it out. When I think in question number 9, you're going to be stuck with a lot of pointer errors. Okay, so please do, when you have these errors, share the error and your frustration in the forums. I think we're getting to a stage in our Reddit forums where and correct me if I'm wrong, okay? Correct me if I'm wrong. I think we're getting to a stage where there's a sufficient amount, oops, not share content. How do I get rid of the iPad thing? I'll just close this, maybe. Yeah. Um, close, does it disappear? Oh, even if I close it, I got to leave the meeting physically, I think. All right, so Face ID is, okay. All right. What was I saying? Oh, I need to leave the meeting. I left the meeting and it's still not leaving that screen. Maybe I didn't leave the meeting. Yeah, I need to, oh geez, where's my leave meeting? Oh, there it is, leave. Okay, all right. Yeah. So that technique basically has worked for me in solving pointer errors. Yeah, in quest number 9, you'll get, yeah, we're getting to a stage in Reddit where I think most of the issues you're running into, you just go and search, you're finding someone else who's had the same issue and solved it. And so I'm noticing increasingly that people are not posting about their problems, right? And I'm just led to believe that. But then I go in and look in the logs. I find that you have actually solved the issue and moved on, right? And I don't know if it's a good thing or a bad thing, because you're finding the solution and moving on. But I think newcomers after you maybe, they may think that, well, not a great deal is going on here, so people are basically giving up. So yeah, I think it'll be useful if you continue to post messages even after you get to 2B and 2C, right? If you face any frustrations, you can say, I had this problem, but I found the solution here, right? Had this problem, found the solution here. Then that way, it also keeps up the excitement for future students when we do that. Okay. All right. So if you guys are okay with what we've talked about so far, I'd like to take a volunteer, and I don't think it's going to take a great deal of time. We'll just create, knock out a stack class right here in the next 15 minutes. We'll just knock out a stack class. If one of you would like to take up the screen, and get on stage and share, a replete or one of those IDEs, we'll start coding right away. Okay. And I think we'll do a stack. Okay, I'll just call out the line of code that appears in my head, and then you guys can correct it. If there's a bug, we can figure it out. I don't think there's going to be a bug. It's a very simple program, right? But you can correct any syntax issues that I have and go from there. Okay, so if nobody else, yeah, thank you, Wen. Take the screen. Take the screen. Take the screen and start up your replete window. Yeah, create a new replete, blank template, right? So just brand new main. And someone please post the code from last class with that game and invite your fellow classmates to take that game to the next level, or even turn it into a web-based game. Post that code, and I think it's a good game because it also introduces you to sorting, which is like central to computer science. Okay, all right. So here's what we're going to do. Because our stack is just going to be a list of items in memory, each item has to refer to the next item, right? So let's say we want to have an array of a stack of integers, right? So our stack, the payload is what it carries, and then the overhead is what you need to put on top of, in addition to the payload, so that the stack works, right? So we're going to create a data structure that is composed of little cells, right? Little cells. We'll call them nodes, right? Nodes. Actually, well, let's call them cells. Okay, cells, right? Cells. Just for the heck of it, right? So we'll call them cells. Each cell will have the integer that we're after, and it'll also have a pointer to the next cell. Okay, so let's go ahead and top of main and create a class. Create a class called cell. Okay, public class cell. Oh, not public. This is C++, right? It's just class cell, right? So you don't have a public qualifying class, right? Okay, cell. Okay, yeah. Put some blank lines there, and then it's a class declaration, so it doesn't have parentheses. It doesn't have parentheses. So just a space instead of the two parentheses, and then an opening brace. No parentheses. Yeah, get rid of the parentheses. Now you got rid of the braces, get rid of the parentheses, right? Space and a brace. Yeah, okay. Okay, all right, your cell. Now inside of my cell, I'm going to have two things, and I'll make them both private, okay? So just we'll so that we'll get the hang of, yeah, private, colon, enter. Okay, so we want an integer value, let's say int payload, okay? And then we want a pointer. So let's say your next private variable on the next line is going to be cell star next. Cell space. Yeah, usually I have a space. Yeah, star next cell, right? Next cell. Okay, all right. So that is my stack cell, okay? So this is what my stack is going to be. Now, my actual stack, I'm going to make it another class, okay? So create another class, a semicolon after that a brace to complete that class. Right, we're going to go back and put in the getters and setters, which you can fill in at some point. Okay, your stack is you call it stack. Okay, yeah, no, yeah, space and yeah, okay, all right. Now your stack class is just going to have a cell. Okay, cell star contents. Okay, and make that private also. Make that private. Okay, now because they're all private, we're going to have to need operation. We're going to make operations on the stack, right? So let's create a bunch of public methods for stack. Say public, enter, one more enter. Yeah, okay, public, yeah, okay, public. And we want to create some methods here. So let's say one of the methods we want is let's say is empty, which will return a Boolean value, right? So say bool space is empty. And it's going to return true if the stack is empty. It's going to return false, right? So semicolon there, right? Just say semicolon for now. Yeah, semicolon. No, we'll define the body later. Okay, just put a semicolon there. Now we need a couple more operations. We want to know what the top element in the stack is before we pop it, right? So let's say int top. Okay, that gives me the last element, right? Well, let's say last, int last. Conventionally, it's called top, but we're calling it last here, okay? Last, yeah, that's also a method. Semicolon, okay? And then we need two more methods. One method to push something into the stack, one method to pop something from the stack, okay? So say bool push, right? So meaning that push, and it's going to take an integer parameter, int val. Okay, Augie says top would make more sense. So turn last into top. Okay, and then we need a pop method, which is going to take the top element and throw it away, right? It doesn't return. Yeah, it can return bool. That's fine. Bool pop. Okay, so these, and a semicolon after the class declaration, we can go ahead and implement these methods now. Semicolon after the stack declaration. Put the class declaration on line 18, semicolon, enter. Okay, now we're going to go ahead and implement these methods, okay? And in the process of implementing these methods, we may encounter a requirement where we need to implement the cell methods too, because, as you can see, even the cell methods are private, right? So we need to implement those. We'll get to that very soon, okay? So the first thing we'll implement is empty. Actually, no, let's say, yeah, let's implement is empty first, okay? Is empty. So what we're going to do is we'll say that the stack is empty if contents is a null pointer, right? So you can just say return contents double equals null pointer. Yeah, okay. All right. So no, null is fine. Or you should either say null or nullptr in lowercase, right? They're both the same. Now, because it's an inline method and it's just one line, it helps to actually put it all in one line, including the brace, right? Open brace, return contents equals null, and then close brace, and then there you go. That's your inline method done right there. Yeah. Okay. There. Nice. Okay. You can even put a space before the opening brace, right? So that it's separated from the. Okay. So your empty is done right there. Okay. And what should a top do? The top returns the top element of the thing, right? Now, what happens if the stack is null? If your, you know, stack is empty, there's nothing in there, and you call top. So that is a serious error, isn't it? Because top returns an integer, and right now you don't have what is called a sentinel. A sentinel says, here's a value, but it's invalid. It wasn't in the container, but you can see it's not in the container because it's an invalid value. We don't have a sentinel right now, right? So we're going to implement a buggy version of top, or rather a risky and dangerous version of top, which will basically assume that when top is called, the stack is not empty. Okay, so top should basically just return the contents of, right? So go to top. We'll implement top right now, right? And we can actually make it safer, right? Safer, but incorrect, but we'll get to that very soon. So return, right? Contents arrow payload, right? Contents arrow payload. What that does is go to the arrow dash greater than, right? And usually people don't have a space after contents when they're using indirection like that. It's contents arrow right there, that space. Yeah, okay. It just returns a contents arrow payload, but there is no contents. Payload is private, isn't it? You can't access private. So what you're going to do is basically say contents arrow get payload and go and implement your getter for your cell. Okay, get underscore payload, and it's a method. So you can say open close parentheses right there. Okay, and then in your cell, you would implement a public method, yeah, colon, yeah, and then get payload will return payload. Int get payload, and then that should just return payload. Yeah, that's correct. You had, yeah, payload, yeah, semicolon, and then you can get rid of the, you can get, your spacing is inconsistent there. No, I don't know. Okay, all right, that's fine. It is the same as the other places. Okay, so that will get. Now, however, because top is dangerous, here's a question for you. Suppose you had the option in your program of your method being called, and you only had two choices. Okay, is a real problem you will encounter several times in your life as a programmer. So think about the answer and chime in the chat window. So you had two choices. One choice is to return the wrong answer. Okay, you say wrong answer. You know it's wrong, but you're going to return the wrong answer. The other choice is to basically do something illegal and crash the program. Okay, those are the only two. There's because you are in a position where you cannot do the right thing. Okay, you're cornered into it's like in life, right? You're cornered into a situation where you can either die or do something bad. Okay, what would you do? Would you rather die or do something bad? Yeah, so it's like a programming moral dilemma. Okay, so here you are in a programming moral dilemma. In top, you can either return the wrong value or you can just die because you cannot do the right thing. So what would you do? Yeah, okay. It depends on the severity. Yeah, okay. So that's right, Augie. It depends on severity. So in our case, and you're right? In our case, we're going to say it's the situation is not so dire as the task I'm asking you to do is not so dire that if you're unable to do the task, don't give up and destroy the whole world. Basically, that's what it is, right? When a function crashes, it kills the whole program, right? A small function that crashes, exits, will kill the whole program. It would die, right? So that's the choice you have. And suppose you're asking that small function to do something very insignificant. You'd rather it fail rather than die. Okay, so in this case, we're going to do something that is equivalent to failing, not dying. So in top, what you can do is say if contents equals null, right at the top, at the beginning, if contents equals null, return 0, right? Or return -1, right? Maybe you say this is a stack of only positive integers, okay? In fact, we can make it even better, right? Make the int payload a size t payload, right? Make the int payload a size t payload, and I'll show you something really cool, okay? Size t, okay? Which means you also have to change the getter signature,
okay? And then your top also needs to change, and your push needs to change, right? Top signature needs to be size T, and your push also needs to take a size T val. Okay, now if your contents equals null, there is a nice sentinel that you can use. Can someone tell me what the sentinel is? You've used that sentinel many times in the past. Okay, what is a sentinel I can use now if contents is null? What is an illegal value? Come on, someone tell me that. Unless you guys are sleeping, right? If you didn't take off. Yes, thank you. It is -1, which in fact, because we're using size T, it is what? And what is that value? There is a value that, because it is used so often, the programmers, the designers of C++ gave it a value, gave it a name that you can use. What is the name? We've used that name before. Okay, the name is string : npos. Okay, so string : npos is your -1, which is typecast to size T, which is a maximum value, right? So instead of return 0, return string : npos. That is your, no, it's all lowercase. It's a string : npos, : npos. So there you go. Now you've actually used a sentinel also, right? So I think you have to use namespace, I think. Standard namespace at the top. Yes. Okay. All right. So now your top will return npos if there is no top, and if there is a top, it'll return the top. Okay. Now all you need to do is in your push, you're going to have to create a new cell and put it on the top of the thing, and the pop is going to just get rid of it, right? And those are like a piece of cake, right? Give me blank line before the method begins, right? After each, also before 19, before 19 also, blank line 19, right? Okay, now push is going to create a new cell and put it there. So what you're going to do here is say cell star new cell equals yes, new space cell semicolon. Okay, it's funny, isn't it? So our new cell, which is a name, a variable name, is a new cell. New is on the right side. On the right side, the new in blue is actually a keyword. It tells the operating system, give me a new data type of, new item of type cell, right, in somewhere in memory, and give me the address of it. So new returns the address where the operating system was able to create a new cell and give you the address. Does that make sense? Okay, technically you can do any new there. In fact, on the next line we're going to delete that, right? It's just an example, not part of the stack class. On the next line you can say int star new int equals new int, right? Or int star new int star p equals new int. You can do that too, right? New int, that's fine. Int star p equals, that's a valid statement, right? It allocates 4 bytes in memory for a new integer, okay, and gets the address where the 4 bytes are allocated and gives you the address which you assign to p. Now p, the value of p is not equal to the value of the integer. It is the value of p itself is the address where that integer is stored. Does that make sense? You can get rid of 28 now. Okay, now that we've got the new cell, what we need to do is take the value and put it in that cell, and put that cell at the top of the stack, right? There's a few things that we need to do, and that's all a piece of cake to do, right? So now you say on the next line, you say cell arrow set payload. No. So this is new. What is it? New cell. Sorry. New cell arrow set payload. Arrow set payload to val. Val. Yeah. Okay. Now is the tricky part. Now we've got the cell and it's got the value in it. We need to put it at the beginning of the list, right? So in other words, here. Oh, I need to join that meeting again. I should have left it joined. Okay, hang on. Just stay with me. Okay, what time is it?
9:46.
Okay, we got 4 minutes. That's fine. Okay. Also, we can continue with this. We can also continue with that later. Okay, join.
Okay, join, share content. Cancel that and join. Not start video, share content. Oh, I see. I can't share the content while you're sharing the screen. Okay, don't worry about that. So I'll just use my hands. Okay, so we've got a new cell. So we've got a new cell, and this is the new integer inside of it. Put in there. Okay, and this is the next cell. It's got to point to the cell that we, the cell that is already there. So what we need to do is take the existing cell, and put it there. So at the cell, for the cell, create a new public method for cell saying insert at head. Okay, so you can say void for now. Let's just make it void. Insert at head, and give it a new cell. Give it a cell star new cell. A parameter is cell star new cell. Okay, semicolon there. Okay, so this method we have to implement, but you can call it here. Okay, so you need to implement the set payload. Okay, just copy the get payload, put it on the next line, and then create the set payload also. Yeah, call it set payload. Okay, and then say payload equals int val, which was passed in, or size t val, and then you can, instead of saying return, you say payload equals val. Now, typically, here's a nuance, right? And it doesn't return size t. It returns, in this case, it returns void, right? It returns void. Now, typically, setters aren't void because setters will also check the value to see if it's legal or not. What happens if I call set payload and give it string colon npos? It's going to set string colon npos in there somewhere as a valid value. But it's not a valid value, right? So typically we're not going to do it here. Typically in a setter, you take the value, compare it to the sentinel, or check it for legality. If it's not legal, you won't do it and return false. If it is legal, you set it and return true. So in that case, your setter will be a true, false, Boolean return. We're not doing that here. But that's what you should do typically, right? So now let's go ahead and so that works. So we want to create another method, inserted head, right? Well, let's create the body of inserted head. We're not going to do it inline. We'll do it out of line. Okay, so do it out of line, after the class, at the end of the class, right? So yeah, enter, 2 enters. Okay, yeah. And then you're going to say cell colon insert. Okay, and then make it void for now. Okay, make it void return. Okay, what does this need to do? All that this needs to do is take that new cell and make that the new head, right? Actually, you know what? The inserted head should really be part of the stack class. That's my lesson for not having thought through this before class. Okay, inserted head needs to be part of the stack class. I'm sorry, right? In fact, it should. No, hang on. Let me think through this. Okay, so we need to. Okay, all right. For now, we'll tidy this up later. For now, okay, just get rid of the private, okay, in your cell method. We'll just access these things here and we'll fix it up later. Okay, get rid of the private. We're going to access, okay, all right, good, public. And in your push method here, we can actually access a cell, right? We can access a cell on line 32, right? So we can access a cell. So, and we have the contents. All we need to do now is set, new cell, arrow, next cell. Was it next cell? What do we call it? New cell arrow. What was it called? Next, yeah. Next is what is it called? Next cell equals contents, and then contents equals new cell. Okay, now this is probably the 2 most confusing lines you will ever encounter in CS2A, right? But you have to work this out on a piece of paper. No amount of me talking about this here or listening to me is going to help. The only way you can understand this is by doing this on a piece of paper. You got a typo there, by the way, when you fix the contents, right? All right, so what that does is you got the new cell, okay? You just created it. That was your stack with contents. You're going to take the new cell and take its next guy and make that point to contents, and then make contents of the stack point to new cell, right? So now, what is at the head of your stack? New cell is at the head. What does new cell point to? The old cell, okay? Now, suppose I do another push, what's going to happen? This guy is now contents. That is going to be get pointed to by this yet new cell, newer cell that you created. That'll point to this guy. This guy points to that guy. Okay, and contents is this new guy, right? So at any time, contents points to the latest element that was pushed. Okay, that points to the most recent after that was pushed, and so on. So you got that sequence built in as in the very process of creating this method. Does that make sense? Now for pop is very straightforward to implement, right? So in pop, what you would do is, let's implement the body of pop, right? Push, make it void. Okay, push should be void. It's not a Boolean, right? Push is void, but right now it's just void. Okay. Yeah, pop should basically say if the contents is null, you cannot pop anything, right? If the contents is null, so you return false right there, right? If null, return false. You cannot pop. Otherwise, you know that you can pop it, right? So how do you pop? You need to do a thing. First, you allocated memory. So you need to get rid of it and return it to the operating system. You can't just throw it away saying, I don't need it anymore. You got it from the operating system, you got to give it back to the operating system, right? So you say, cell to discard. Okay, so cell star cell to discard, cell star cell to discard equals what? The cell to discard is in fact contents, the first cell, right? Contents, right? Now because you're cell to discard is contents. Okay, all right. Now you can delete contents, right? Cell to discard is contents. Now, okay, now you say contents equals contents arrow next. Contents equals contents arrow next. Now what you've done is that you have this chain, okay, and you took that link that was pointing to the first bead of the first element, you took that link and made it point to the next one. Now this thing, the first bead, is still there, but nothing is connected to it. It's just floating, right? But it was given to you by the operating system, so it's only right you give it back to the operating system. And the way you do it is by saying delete contents, right? Or delete cell to discard, because that was a cell that you pulled out, right? And you don't need parentheses there because delete is a keyword. It's an operator, not a function. Okay, so there you go. All right, maybe there's a couple bugs in here, but we completed it. That's it, right? And we haven't written the driver. Driver meaning from main, we call the methods and try it out. We can do that next class, and it's a piece of cake, right? Because it's also related to linked lists, which we'll do next class, right? So we'll do it then. But this is your entire stack class for now. It's with all the crucial, the important methods implemented, fleshed out right here. And now what we should do, do we need a way to set Augie had a question. Hey, anyone who had a question, you should speak up, okay? Because you have these questions in chat. I'm not looking at the chat. I'm looking at the code window, right? So, do we need a way to set get the next cell? What do you mean? What do you mean? There, no, you can't.
That wasn't a question. That was a statement before we changed it. So the variable.
Oh, I see. So it's answered now.
Yes.
Okay. All right. So. So what you can do if you feel you need to understand this more is basically work it out on paper. Okay, this will not make sense to you. I can guarantee it will not make sense to you until you work it out on paper at least once, right? So work it out on paper. You're saying, okay, this is my cells. These are my cells coming in, and every cell that comes in goes here, here, here. Okay, now I got a chain. When I pop things out, it's going out in that way. And every time, every new has to be matched with a corresponding delete. If you don't match up your delete with a new, then some memory is being gotten from the operating system, but it's not being given back to the operating system. It's called a memory leak, right? So when you have a long-running program, a program that never dies, like a daemon, and you have a memory leak in there, you're basically screwed. Because anytime you get memory, you're not giving it back to the operating system, your program will start getting bigger and bigger and bigger. Okay, and you start suffering bloat. It's bloatware. Like, your program will become like Chrome, right? How many times have you started Chrome on a Mac or a PC, right? And you say, oh, it's not using up a great deal of memory, but over a period of time, if you leave it running, it gets bigger and bigger and bigger, right? Because there's probably bugs in the program. Bugs where the programmers, I don't know, right? I bet, when it first came out and they were all rockstar programmers, it was, squeaky clean and bulletproof. But I'm pretty sure in a large company, you do have some programmers who don't know what they're doing too, right? So I bet there are memory leaks in Chrome. right? And so when you leave that program running for a long time, you can see, you go to your activity explorer or something like that, you can see your task manager, your program gets bigger and bigger and bigger, and it also gets slower and slower and slower until and sometimes at one point it can't do its job at all. It's gotten so fat that it can't even move sideways. Okay, it just freezes, and you got to kill the program and start again, right? So those are marks of programs that were designed by programmers who did not really think things all the way through when it comes to memory allocation and pointers. That's why you got to be like super duper careful. If you can look at programmers, even at places like Google and Microsoft, who write programs that have pointer errors and memory leaks, right? Then you can imagine, and those are programmers who've had a lot of experience, right? Many years of coding, right? And sometimes, doesn't matter how good you are. Doesn't matter how good you are. A lot of factors go into whether you get pointer errors, right? What happened on a date the previous night, okay? What do you have for dinner? What do you eat? Or whether you're, coffee. All these things bear, or someone yelled at you, have a bearing on whether your program will have a pointer error in it, because it's hard. And so no matter how good you are, you got to be really good at Sherlock Holmes, at getting to the bottom of these pointer errors. So it's really good practice. So try playing with pointers, starting with stacks, okay, and run into as many pointer errors as you can when you're still a student, okay? If you try and shy away from pointer errors, right, saying, oh, if I do this, I might get a pointer error, I'm not going to do that, I'll do it in a different way which doesn't require pointers, okay, well, you're not going to be a successful programmer, okay? Yeah, I can actually say that with a great deal of confidence. Okay, so when you're a student, especially in a class like this, right, is your best chance in your entire life to go searching for problems. Okay, it's like when you're a kid or a teenager, is your best chance in your life to go looking for problems where you will fail and do the wrong thing, as long as you know for sure that you're covered and you're not going to die, or some really bad shit is not going to happen to you, right? So you got someone who knows, who takes care of you, says, okay, they're going to do some really crazy things here. I'm not going to tell them to not do it, but I want to be here just in case it turns really bad. I can go in and rescue them, but I want them to do it so that they can get bitten, right? So this is your chance to get bitten, okay? Don't shy away and don't run away from these errors. Go looking for them. Great. Try and make these pointer errors. Try and get bitten, get frustrated. That's the only way you can get used to them and get inured. Okay, this is getting inured to pointer errors is the best way to conquering them later on. Not even conquering them, right? To say that, oh, I got a pointer error, I go and fix it now, right? So you'll have that mindset rather than, oh my gosh, I got a pointer error, I don't know what to do, right? No, you should get to a place where you say, okay, well, I've got 10 pointer errors now I can go and fix them all one at a time, right? Right? This is by that pointer error, it'll probably take me 2.5 hours to fix, but I can do it, right? That is in 20 minutes, that's 2 minutes, okay? So you get an idea of how long it's going to take you to fix what kinds of pointer errors. That kind of intuition is really, really hard to get, and you'll only get it when you've encountered like a million pointer errors. So go ahead and code and get pointer errors, crash and burn, okay? But don't kill yourself, right? So make sure that you get frustrated, but not to the point of, when I mean kill yourself, not to the point of giving up on C++, right? Don't let it scare you away from C++, because there's an enormous wealth of beautiful things to discover, but you can only discover that after you get past the initial, jungle of wild beasts, right? So once you know how to navigate your way in the trail, through all these complex creatures, right? And on the other side, you have the Garden of Eden. Okay, so that's where we're at. I think we actually made some major headway here. We implemented a complete stack. The only thing we didn't do was use the stack. You can get rid of the function inserted head, right? So 13, 14, 15. One thing you guys can do, lines 13, 14, 15 can go, right? One thing you can do is share the code in the forums, and here's an exercise for you. Now turn both the members in your cell class to be private, right? Make them both private, which means that your pop cannot be so trivial, right? This is going to be slightly more complex, maybe 4 or 5 more lines you have to implement, because your payload and next cell are now private, not public. So so make it private and still make the program work. Okay, and in your main, create a stack, and in a loop, push 10 items on the stack, And then in another loop below that, pop the 10 items one after another. And before popping, do a top and print the top item, right? So you should see it come out in the exact reverse order, right? For last in, first out. Now test it out. So I would like, why do you have an underline under new cell arrow next cell? Oh, you turned it private. That's why. That's why. Okay. Yeah, when you had it public, it wasn't underlined. So when you make it private, you got this error, you got to fix it. Okay, so you got to fix the push and the pop after having made your cell elements private. Does that make sense? I think we covered a significant topic today, and we got to the end of it too. What time is it now? Oh my gosh, it's 10:02. Oh, yeah. Okay. I'm surprised a lot of you are still around. Obviously, you know, we're going to record this and put it online. So, but still, was this useful to you guys? Did you guys get something out of this class about pointers and stacks? We covered both of those topics in a single class, but we'll, you know, continue talking about it next class also. Also, by the way, please check with your classmates on Slack or anywhere else if you want an Ask Me Anything class, not a class, an Ask Me Anything session, not for any period of time from, you know, 10 minutes to 10 hours. Why not 10 hours, right? 10 minutes to several hours on Thursday. I'm happy to do that. So check with your classmates. And if you do want a session like that, ask me anything. And I will be glad to do that on Thursday. Okay, but let me know on Wednesday if possible. Okay, so that I can make sure if someone else asks me to, you know, for something, or, you know, it's a social or something, I can say no. This is more important to me than social engagements. Okay, is that good? All of you? Yeah, just say yes. Otherwise, thank you. Thank you very much. Yeah, Wen, thank you so much for participating and coding for all of us in class today. I appreciate that. All right. If you don't want me to talk to you on Thursday, I will see you on Tuesday. But I hope that maybe some of you want to listen, you know, have things to generally chat, you know, a casual discussion on Thursday about the exam, about anything. We can talk. Okay. If you find all these, you know, sideways ramblings useful, we can absolutely talk. All right. Thank you very much for attending class today. I will see you otherwise on week 11, on Tuesday, week 11. Right? And we'll talk more about pointers and linked lists in that class. Okay. I think that's it. I should probably stop just in case some of you are here just out of politeness. I should let you go. All right. And thank you again.